Hello and welcome to From Developer to Architect, Perspectives on Taking the Step. This presentation, whilst it does have that title, is actually aimed at any individual who wants to think about architecture or think about how architectural concepts can impact their decision making at work. This presentation was originally given at Forcelandia, which is a Salesforce community event set in Portland, Oregon. And as such, it's a little bit left of center in order to keep the audience engaged. So strap yourselves in. Things are going to get a little bit weird. But before they get weird, we're going to start with a traditional agenda. I'm going to define what is architecture. I'm going to talk about the difference between being a developer and being an architect. I'm going to discuss some of the general goals of architecture, and then finally I'm going to end with a bit of a speed run that takes you through a whole bunch of random concepts that I think you should know about. Now, get started. These are my principles, so this is my view of the world. And like Groucho Marx said, if you don't like my principles, I do have others. But these are the ones I want to talk to you about today in terms of the architecture. So, lots of movie references here in this presentation. So for me, architecture is a bit like an ogre or a cake. It's got a lot of layers. And sometimes it's like an onion because it also has lots of layers and it could make you cry. When I first got into architecture, or even now when you go looking for architecture on the internet, you'll often find a lot of diagrams that look a lot like this. So lots of boxes, lots of lines, lots of circles, lots of colors. And often when I read these things and I stare at them, I think, what is going on? What are they talking about? This all seems terribly complicated. And if you go and read TOGAF, I think its introduction for what is architecture runs for a couple of pages. So the first thing I'm going to do is I want to settle on a definition of what an architect or what architecture is. Not what an architect is, but what an architecture is. So by definition is this: an IT architecture is a mechanism by which an area of responsibility is structured to be fit for purpose. Now, I mentioned the word IT architecture because obviously there are real architects who design buildings. And we just do a pale imitation of it. But in my area definition, this is what I think. Now, there's a couple of key words in here. The first one is this concept of area of responsibility. Whether you're talking about a function inside a piece of code, or whether you're talking about a subsystem within a larger system, or you're talking about the whole system, or you're talking about a cluster of systems in a responsibility area, or you're looking at the entire enterprise, then this is really where part architecture sits. So it's really about matching or the design of a system within an area of responsibility, right? And you define that responsibility as the scope of your architecture. And really architecture is about structuring things. It's about deciding what things what parts of a system are responsible for what functions and how they communicate and interrelate with each other. And the final thing is really important because an architecture is not necessarily right or wrong. What it needs to be is fit for the business purpose that it was intended. Okay. Now, some business purposes are simply disposable. People want to get something done in order to launch a product to market, but they're not looking for it to last, 20 years. It might, unfortunately, end that way, but generally you have to take the business's advice at face value and design a solution that is fit for purpose. And if they're not being clear about what they want it for, one of your jobs is to really get an understanding of how long you want this thing to run for. Okay, so what's the difference between a developer and an architect? Well, Forcelandia was a pretty casual place, and it did mention beer in its description. So I assumed a beer metaphor would be appropriate here. If a developer's job is a single bottle of beer, then an architect's job must be a lot more, right? It must just be more. It must be more complicated. And therefore, it's just the same thing, only more of it and harder. But that's not really what I view it as. What I view as architecture is a different way to look at things. So, to give you the beer metaphor, to stretch that and continue that, a developer may look at this beer and say it is a beer and it is made by Foster's, and that's how they look at the world. But an architect may look at this and think, well, actually, it's a type of alcohol, and the purpose of alcohol might be to bring you some form of temporary joy. Now, apologies to anyone who's a non-drinker, but that's one view of the world. A slightly less or more inclusive metaphor or example would be this example of cars. So if you asked a mechanic, they might argue that these two vehicles have very little in common with each other. They're not made by the same people. They share no common parts between them. They really are two entirely different things. But from an architectural perspective, these cars are actually identical. And the reason that they're identical is that they fulfill the same purpose. They are both petrol-powered 7-seater vehicles. Right? And if my business purpose is to move 7 people, then these vehicles, either of them, will fulfill that goal. And whilst on the surface they're very different, the actual core of their nature is actually the same thing. And hopefully that's an explanation of a different way to look at things as an architect. You're not necessarily straining over the minutiae, you're stepping back and you're looking for the overall pattern, the overall purpose of what that function is. Now, the trouble with the word architect is that it's really popular. Okay, so everyone wants to be one when they grow up, and some people want to be the one when they haven't yet grown up. So it's a very common thing, and as such, you get a lot of different types of architect turning up in this world. All the ones listed here. In fact, sometimes it feels like everybody's an architect, that everyone wants to be an architect. Is that a good thing or a bad thing? Well, maybe when we talk a little bit further about some of the impacts of that, we'll revisit that question. Now, when I am talking about architects in the context of this presentation, I'm really talking about the architects here in bold. Application architect, solution architect, enterprise architect, data architect, integration architect. And these are the ones that are most relevant to Salesforce. As such, they'll be the ones that we focus on today. Other types of architect are less relevant in the Salesforce context. Now, as you can see from the definitions I've got here, an application architect is really focusing on the internal design of an application. A solution architect might overall look at the overall design of an end-to-end solution, and in Accenture contexts, a solution architect is actually a pre-sales role, and it's as much about the commercial aspects of the solution as it is about the design aspects of it. An enterprise architect might look at have responsibility for the architecture of the entire organization. Data architects would focus on the data model and the interrelation of data within within a system. And integration architects are focusing on how systems interconnect with each other and the data that gets passed between them all. Now, if you're an Orphan Black fan, you'll get this slide, but really what we're talking about here is those roles that are described on the previous slide in a large organization would be fulfilled by multiple people. So each role would be a separate person and they would work together. And indeed, you'll often find that there's an architect for each application. So rather than there simply being a one for each type of architect, there's several. In a smaller situation, you might find that one person fulfills many roles, and so today they're doing integration architecture and tomorrow they're doing data architecture and so forth. And really this proliferation of roles is where one of the aspects of complexity comes in systems, and what the difference is between working in an enterprise and working in a small business. because one of the concepts that comes up when you're talking about this is Conway's Law. You can go and look up Conway's Law. It's out there on the internet, and really what it's saying is that organizations who are going to build a system are going to build that system in the same structure in which they structure their organization. So what it means is that if you're, and they talk about copies of the communication structures of an organization. So if you have a front-end team and a back-end team, or you have a digital team and an SAP team, then you're going to wind up having a system that has, a digital layer and an SAP layer. And really it sort of this follows on from that. So the ramification that I see is that there's if you have a lot of architects and each one of them has a small area of responsibility, then each of those areas of responsibility will be made more complicated by them, and pretty soon that's how you wind up in an enterprise context. Right, so a decision that would take maybe 1 to 2 people a few hours to make in a smaller, more agile environment may take several weeks, months, or years for many people to make in an enterprise environment. And as you break out these responsibilities, you wind up with the greater levels of complexity. So concepts like small Scrum teams or integrated teams or DevOps teams, I think, are in some ways reactions to this problem. So why do you care about architecture? Who cares? And that's a valid question, because out there in the world, sometimes the word architect carries a lot of connotations, and many of them aren't positive. For instance, there's this concept that an architect lives in an ivory tower, and the real people that do the real work, toil away in the darkness. Now, my friend John Eves has written a great blog post about being an architect, and he's got this quote here that's saying, being an architect in the computer industry is some old white guy who's completely forgotten anything about software development and spends all his day writing PowerPoint presentations on choosing WebSphere versus WebLogic, and then they inflict this on the organization like stone tablets. Really depressing worldview, but often sometimes can be the case, right? Now, if you read the blog post, you'll find John has quite a radically different take on what an architect should be. An architect should be someone who's in the trenches, who's rolling up their sleeves, who's solving problems or helping teams solving problems, who's coaching them towards a direction rather than simply mandating an outcome. And I really like that as a concept. Now, so often the blowback to these sorts of problems is to simply say, well, we don't need architecture. Well, that has another side effect, and bonus points if you recognize the game. But you can die of lack of architecture, or rather your system can die of lack of architecture. And really these goals sort of sum up the 4 ways in which an application, I feel, or a system can fail. So these are the goals that we'll drill into in greater detail. But they're really around the things you should look for when going about designing and building a solution. And there's a reason they're in a numeric order, because they're the speed and the horizon at which systems can fail. So if you build a solution and it does not fulfill the business goals tasked to it, then chances are the system will fail before it even begins, because no one will use it. And so a system that isn't used is a system that doesn't fulfill its purpose, and so it fails at the first hurdle. Now, once you've got people using it, you have an issue there in which it needs to be reliable, right? So if the system is unreliable, then trust in the system falls away, and without trust, there is not a lot of success in the system. People will start to work around it. They'll build compensatory systems around it. They'll avoid using the system, and eventually the system will fail. After you've got the system reliable, then obviously it needs to be amenable to change. Now, any system that succeeds will be changed, right? Because you never got it right to begin with, and people's needs change over time and things evolve, and so systems evolve with it. So this ability to change over time People might sum up as favoring configuration over code, or they might talk about it being DevOps, for instance, in order to do releases quickly, and we'll talk about that a bit more. And so it can be a very, very significant and important thing. So people will say, I only want out of the box features. I don't want you to affect the upgrade process. These things are all basically related to being amenable to change. And finally, the system needs to be sustainable over its lifetime, and that means you need to be able to maintain it and support it and make it do what it wants. And this ability to not be able to sustain a solution is the final reason a system will be failed or discarded. So after you've got everyone to use it, after it's reliable, after you've been able to make some changes, there will be a point in time where it may reach a steady state. The people who built it have gone, the people who've maintained it have gone, and now the system they can't find the people to look after it. No one wants to invest in looking after it, and so they throw the whole thing out. So let's deep dive into these 4 points in a bit more detail. The first one is really around business goals. So when you walk into a situation, you really want to be understanding the business goals that they're trying to achieve. And these questions are some of the questions that I might ask. You'd want to know what the activities are in the business. You want to know what types of things they do. Do they make things? Do they support things? Do they service things? You want to look at how they make their money. Do they make money from leasing things, from being a middleman where they take money in a transactional sense, or are they a finance company, or those sorts of concepts? How do they make their money? What's the structure of the business? Is it a franchise model? That's a very important thing to know. Is it a conglomerate? Is it made up of a number of different brands? Do each one of those areas have their own IT department, or do they have some kind of shared surface? Another thing to ask is how many people work in each area, right? We want to get a size of the scope of the problem and a handle on in which areas people are, and where the areas of complexity might be based around staffing, or you might find that something that somebody has said is very significant actually has a relatively small number of people associated with it. So that's important to know. Along with things like locations, are they located in one city? Are they spread across the country, across the world? Do they have staff who are mobile? These are all things that you want to know. Goals of the business, what are they trying to achieve? Lower costs, raise revenue, increase the diversity of their sales, increase upselling, lower their cycle time to sell, so they can sell faster. What are the internal capabilities of the business? Do they have a software team? Do they have a support team? Do they have a marketing team? What things can that business do, and what are they capable of doing? And finally, what are their key challenges, which is in some ways related to the goals of the business. So what things are they really wanting to focus on that this system or this solution or this thing we're doing will help them resolve it? The next point is really reliability. And I see reliability in a system being affected in a couple of ways. I see that there's a problem with inappropriate responsibilities, right? A system is, part of a system has been asked to do something that it should never have been asked to do. Maybe someone's bought, a third-party product, and they've decided that third-party product should do a whole bunch of things it wasn't supposed to do. And so or have they bought a technology that's not right for the problem? And so because of that, it's just never going to work, right? And it's always a bad fit, and it's always complicated, and it's always harder than it should be. And as such, it's just not reliable. Are there an inappropriate separation of concerns? And that's a fantastic phrase to learn, separation of concerns, but it's really about, is there really a clear set of responsibilities that you could break a system down to, and is there an easy or clear way in which they intercommunicate with each other? Or do systems have to have a very intimate knowledge of their surrounding systems in order to work? You know, a classic example is two systems that exchange data by modifying each other's databases directly rather than calling some kind of API. And technically, you know, calling the Salesforce web services that update the Salesforce objects is that same kind of problem. You have to have an external system with a very intimate knowledge of your Salesforce instance in order to, say, correctly convert a lead or correctly update opportunity products or some kind of thing like that. And that results in systems becoming entangled and acting in strange ways when you change things. There's concepts of insufficient resilience. You know, everything fails, right? Every network connection you make will fail. Your batch jobs won't run. Some call out you make will just not be there and responding. When you call things, things will happen potentially out of order, particularly if you're making asynchronous calls. You have to assume that things are going to fail, and you should build to assume to cater for those kinds of failures. And the final thing is really the build quality, right? So it's the actual quality of the code where you've written code. You know, are you using the right standards? Have you used the right best practices? Have you followed all the rules in writing good scalable Salesforce code? Those things all affect reliability. And reliability affects trust, and without trust, everything is hard. Are systems amenable to change? Okay, so what I see in terms of things being able to be changed is you've got this problem of separation of concerns. You've got parts of the system that are fuzzy in how they interrelate with each other. They've got dependencies on each other. There's spaghetti code. Because of this, people are afraid to make changes. They don't know the outcomes of making a modification because there's so much entanglement. You just can't tell. You just make a change and maybe hope. You know, unit tests may help, but clear boundaries will be the best way to solve that problem. And microservices is really popular because for this reason, because you know you've got this thing that you can only connect to over an HTTP connection, and it's remote from you, and you really can't talk to it any other way except through the interfaces it provides. And another mechanism issue is this organizational capability. So a lot of businesses are fearful of change. They only make releases every month, every quarter, every year, because change is hard, and no one knows how to do it, and no one knows what's going to happen, and we're afraid and we're worried about the situation, you know, and that's things like lack of documentation, lack of people reading the documentation. It sounds silly, but very much true. You know, you can often write a manual and no one looks at it, and really concepts like DevOps and continuous delivery are here to try and fight this kind of thing, right? They're trying to make change as painless as possible by making you change all the time. If you change things all the time, then each subsequent change becomes easier and cheaper. And so that's the way of inoculating against this problem of sustaining of being amenable to change by doing it all the time. And the final concept is really sustainability. And what I see here is things like a lack of organizational capability. So it's a company, you know, with a background in .NET who's adopted Salesforce, and they don't know much about it, and they're really not in a position to support it. So one particular company I know I've seen was a .NET shop, and they adopted MuleSoft. They had no idea about Java, no familiarity with Java. And so adopting the Java toolchain and everything that went with Java was actually really hard for them. And so problematic. There's a lack of organizational commitment to keeping things up to date. You know, they spent a lot of money building it. They didn't want to spend a lot of money maintaining it. Things like transient technology choices. There's a lot of churn, for instance, in JavaScript frameworks. It's entirely possible you might start a year-long project, and by the end of the project, your JavaScript framework that was the hot thing at the beginning of the year is not the hot thing at the end end of the year. And so that kind of thing is a consideration. It's not to be said that the difference between, say, an Angular application and a Lightning application is simply that Salesforce will no doubt support Lightning for much longer than Angular people will support Angular, and versions of Angular 1 and Angular 2 where they're really quite different. Are examples of those kinds of situations where the community isn't necessarily going to supply something for a long period of time. And finally, it's things like high ongoing costs where people just get weary of the money it costs to keep the lights on. So hopefully those have given you some insights into sort of those four kind of concepts. Now I'm going to jump over into a speed run and excuse me, it's a bit late. Take you through a whole bunch of different topics that aren't, sort of not related to each other, but I think are things that guide me. The first one is the most important thing I learned, and that's really about the data model. Okay, so your data model basically expresses the capabilities of your system. If you can't represent the concepts that your system will act upon in its data model, then they can't perform those actions. Obviously, if there's no object for loans, then you're not going to be able to build a loan system, but it's more nuanced than that. If you take something like, the best example would be the addresses in Salesforce. So there's two address fields on the account object. So basically now your data model says that you can only have two addresses for an account. If you want a third address or a fourth address, then you've got a lot of work to do to solve that problem, and that's a base level of the capability. Obviously in Salesforce, your data model drives everything. It drives your user interface, it drives your security model, it drives your reporting, it drives your integration patterns. Basically, if your data model is poorly designed, you will wind up with an application that is made up entirely of custom code, because none of the process builder won't work, the UIs won't work. You've got to build a complete custom UI, complete custom automation using triggers, and your security model may not work. So it's a really important thing to get right and not one to be glossed over. Now the subject of data modeling is a vast topic, but hopefully I've given you some indication of the importance of the data model. The second thing is really this concept that the fashion fades, but style is eternal. And by this I mean that behind a piece of technology is a concept, and that concept is there's not too many of those concepts, and what you tend to find is pieces of technology that come out are actually re-implementing concepts that have already been implemented before in some other technology stack. So the classic example might be Salesforce like platform events. Platform events is a new technology in Salesforce, but it's not a new concept at all. It goes back to message-oriented middleware I was reading about and working with in 1999. 98 products like Tuxedo and MQ series and so forth that later evolved into products like Rabbit MQ and so on. Now finally, become Salesforce platform events. Once you recognize the concept in the same way that we talked about the minivans, then you can see that concept repeated in new technologies. So just remember that nothing necessarily is new. Mainframes were doing this 40 years ago. Another one is this concept of keeping things simple, stupid. So the KISS principle. And I've never seen an architecture rewarded by complexity. Often people think that in order to be good, it must be complicated. In order for it to be serious, it must be complicated. And I really don't agree with that. Simple is the right way to go. And the most simple, elegant solution is the right solution. So where you have an opportunity to simplify, and one classic example would be trigger frameworks. There are trigger frameworks out there where it takes 9 Apex classes in order to implement one trigger handler. There are other ones where you can do it in 1 or 2 classes. Now my preference would always be to go with the simple solution and not the complex one. Complex means more moving parts. More moving parts means more things break. More things break, less reliable you are, and then less reliable you are, the less trust you have, and it's all downhill from there. Okay, so another idiom or concept is this idea that a good architecture now is better than a perfect architecture next week. You can spend an infinite amount of time sitting in front of Visio and PowerPoint, staring at a series of boxes, making decisions. And many businesses, for instance, when they come to do their enterprise architecture, may never get past that stage. My theory would be that you should test your theories, right? You should build it, go out and build it, incrementally build it, iterate over it, extend and improve as time goes on. Think about the concepts, postpone the implementation. And something that you've moved forward with in a straight line is better than sitting on it forever, contemplating your navel. Bonus points if you recognize the line. It's a terrible line and a not so great movie in my opinion, about sand. I don't like integrations. It's coarse and it gets everywhere. And integrations are a problem space, right? They're always often more challenging than people expect. They often are problematic in that they need to be built a couple of times before they're right. And they're really one of the areas in which a system can go a little bit wrong. So one of the things I look for in integrations is the data model compatibility between two systems. Are they representing fundamentally different concepts in their systems, and thus there is not really an easy way to transfer information from one model to another model. The best example I give is the concept of a motor vehicle registration system where you might have one system that's person-centric, so people have cars, and another system which is car-centric, so cars have people. And so now you wind up with this situation where two cars in a system are actually two separate records with two separate drivers, both whose name is Stephen Herod. When you map it across to this target system, and that target system has one person named Stephen Herod with two cars, you've got some problems. How do you synchronize, for instance, a name change on one of the drivers in one of the systems back over to the other system? So there's a non-trivial problem, and often something where I see people go horribly wrong. Another thing is to look up the fallacies of distributed computing, which is an interesting couple of bullet points, but it says things like don't assume the network is reliable. Don't assume that latency is zero. If you make 5 web service callouts in order to complete a transaction, you now have 4 ways in which things can fail, 4 ways in which things can go slow, and maybe you'd be better off with just one web service callout. These are the important concepts, and directly related to that reliability question we were talking about. Another favorite topic is this concept of the magic box, and I always quote the song, and no one ever knows what I'm talking about, but if you go look it up, on this album, For They May Be Giants, Spirally Shape, there's a line that says nobody knows what it's really like, but everybody says it's great. And I've certainly come across solutions where someone has a magic box that will do everything, and don't you worry about that, the magic box will do it. And sometimes that magic box is called middleware. Sometimes that magic box is the system that has not yet been built. And it's always good to understand these magic boxes, because you often find out that when push comes to shove, those responsibilities aren't fulfilled, and now you're in a situation where you now have to build compensations back into your system. So really explore these things, and really mark them out and understand what the viability of what's been going into, and contemplate what would happen to your architecture if that magic box was unavailable. I'm not saying necessarily build it, but I'm saying think through the ramifications. Which leads us nicely into this one, which is about making the least worst choice, like either of these two jumpers. So when you're faced with decision making, you're often not faced with a clear right answer. You're often faced with the ability to choose between two or more bad answers and choosing the least worst of those two answers, or two or more answers. And my way of doing this is really to play forward my decision making. So if I say the answer is X, what are the ramifications of that? How does that change the next thing and the next thing and the next thing? And if I play forward all of those decisions, do I wind up in a place that I think is the right place to be, right? So if I use a standard object, it will mean that I will be able to do X, Y, and Z, but not the A, B, and C. And am I happy with that, or should I go with a custom object, and will that allow me to do more or do less? And so those are the kinds of things that I'm making. So it's really play forward your decision making, understand the downstream ramifications of that decision on your own design, on other people's systems, and think through the ramifications of that. Another thing to understand is the roles of soft skills like influence and persuasion. So a lot of what you're doing in architecture is convincing people that it's going to be okay, that the solution is the right solution, that it fulfills their requirements. You might have a disagreement with someone about the way in which things should be built or should be structured, and so you should really look at mechanisms you use to persuade a person or overcome objections or move a group into the framework of the answer that you wanted them to follow. And really that shouldn't be understated. There's so much of, I know what I do is basically around providing a sense of assurance that things are okay and that things are going to be okay, and persuading people that a course of action is the right course of action. Another thing is this quote from Top Gun: "Your ego's writing checks your body can't cash," and really what it's saying is that you as a technologist or you have things you want to try. I really want to try platform events. I've never done a project that uses this particular technology. We should do that. Well, that's the wrong answer. The right answer is what's right for the customer, not what you'd like to play with. Now, you might see that a new thing has some capabilities that are useful and that they'll be something people can leverage, and that's the criteria you should use for making the decision, not because I've got my Salesforce certification in 2 weeks and it'd be really good if I got to play with it. If you're doing that, you're being a bad person. Okay, this one from Aliens. I say we take off and nuke the entire site from orbit. There's a reaction to a lot, particularly amongst programmers, to coming in and looking at code and going, oh my goodness, what is this? How did anybody let this happen? We should throw the whole thing out and start again. Well, with a class, an individual class, that might actually be the right thing to do. It might be the fastest thing to do. But the problem with that is that writ large, it actually becomes a significant issue, because often when you start that second system where this time you're going to do it right, you wind up with something that's over-engineered and bloated and terrible. And so you just have to have respect for systems. A legacy system is a system that means it has been so successful that it's lived longer than anybody ever expected to. And to simply throw it out or throw things out with the bathwater because you don't like them is not a good thing, because if you go to rebuild it, there's a strong chance you may not be making it any better. So think about that one when you're making your decisions about what to keep and what to throw out. And the final point is something I think is really important, which is that, this quote from Batman: you either die a hero or you live long enough to become the villain. Which is true. Systems, even last week I got called in to talk to a customer who was thinking about replacing a system that they said had been badly built, which had been or had various issues. So that goes back to a system that I'd been involved putting in. So circle of life and all things. And you should just, the adage at the bottom that every decision you make is wrong, just not yet, is very true. When you make a decision, you make it based on the information that's in front of you. Time changes and time moves on. A lot of the facts you've relied on actually change. The reality changes. The decisions you make now are invalid because the situation has changed, and now people stand back and look at your system and go, my God, what were they thinking when they did this? Not realizing that they're now in a different place than when you started. And once you recognize and accept that, it does give you a little bit of freedom, because you don't necessarily have to stress that you have to be it right for all time. You just have to be right for the set of preconditions that you've explained and documented and justified yourself towards. And if those preconditions change, then the solution will need to change as well. So hopefully that's been useful. Thank you for listening. Thank you for watching, and I hope you have a great day.